Hey, hello everyone. Welcome to our channel Physics, where we actually learn physics. So in this lecture, we are gonna solve this problem that you can see on the screen. Okay, it is 2.14th exercise in your textbook. Actually, this is from 11th standard. Okay, this is chapter 2. Okay, that is units and measurements. This is from the CBSE board. Okay, so let's solve this. Let's see what it is. The question says that a book with many printing errors. Okay, a book with many printing errors contains four different formulas for the displacement of a particle undergoing a certain periodic motion. So there are four equations that you can see given. Okay, out of these you can see some few things are given. Let's zoom this up a little bit. Yes, here you can see some quantities are there, like A, there is T, okay, there is capital T, there is V here, okay, there is capital T again here. Okay, so what are these? See, A is the maximum displacement of the particle, V is the speed of the particle, T is the time period of motion. Okay, so these are the few things that are given to us. Now what we have to do is, see, rule out the wrong formulas from on dimensional grounds. Okay, so using the dimensional analysis, okay, checking the dimensions of the equations, okay, find out which equation is wrong, okay, which equation is incorrect, which equation has got errors, okay, printing mistakes like here. Okay, so that is what we have to do in this question. Okay, so let's analyze each one of them. So here you can see first equation is y is equal to a sine 2 pi small t. See, small t is also time, capital T is also time. Okay, this is first equation. Now we have to check these equations are correct or not on dimensional grounds. That means we have to use dimensional analysis over here. Okay, so what does dimensional analysis say? It says that the dimensions on RHS, okay, must be equal to the dimensions on LHS. Okay, I think I have replaced them. Okay, anyways, but you get the idea that RHS dimensions must be equal to LHS dimensions. Okay, that means, for example, if you can see here y, what is y? Y is a displacement, as they have said here. Displacement is nothing but length. So here on the LHS, okay, on the LHS the dimensions are L raised to 1. This is the dimensions on LHS, okay, left hand side. Okay, same should be the dimensions on the other side. Okay, same should be the dimension on the other side. Whatever is the dimension here on the LHS, that should be dimensions here on this. Okay, so this test should be passed. Okay, if this equation passes on this test, then we can say it is a correct equation. Also, you need to know few things, like here you can see there is a trigonometric function, that is sine of something. So it is sine of 2 pi t upon t. Remember this term that you see inside the sine function, that is 2 pi t upon t. Okay, see, whatever term is there, like I say sine of a, for example, whatever term is there, that should be dimensionless. Remember this, that should be dimensionless. Okay, because this sine function only accepts values like, you know, degrees, like it accepts angles, like it accepts like let's say 90 degrees, just example, or it accepts other unit, that is radians. Okay, so this is what it accepts actually. Okay, it should be dimensionless. Okay, whatever is the quantity inside, whatever is the term inside this sine function or any trigonometric function, that should be dimensionless. Also remember that the sine function itself is dimensionless. Okay, so the term inside should be dimensionless and the sine function itself is a dimensionless. Okay, so these are some tests that this equation, any equation over here, should pass through. Then only we can say it is dimensionally correct. Okay, so let's see first of all this one here. Okay, over here this is displacement, so on the LHS it is L raised to 1. Okay, here A is what? A is maximum displacement, so it has got dimensions of length. Now this term, look at this term is 2 pi t upon t, so this tt, okay, that means what? It has got unit second upon second. That means there is no unit, that means there is no dimension to this. Okay, that means the term inside this has got no dimensions. Look at this pi. Pi is measured in radians, so that is fine. That is no problem. Okay, so that means this term over here is fine. Okay, and that it actually passes on the test. Okay, so that means this equation is correct. This equation is dimensionally correct. Why it is correct? Because the dimensions on both sides are equal, as well as the term inside this sine function, it has got no dimensions. Okay, the sine function as a whole also does not have any dimensions, so it has passed on all the test. Okay, and that's why it is dimensionally correct. Okay, so this one is correct. Now let's check this one.